My name is Ogeyin Vanessa, a 500 level student of the Department of Polymer and Textile Engineering, Ahmadu Bello University Zaria. My team is aimed at solving the problem of open air method of carbonization of hydroxyapatite. Over the years, the synthesis of hydroxyapatite has been a little difficult due to the large amounts of fat and protein in the natural sources of hydroxyapatite precursors and the low mechanical properties of the derived scaffolds. Open air method of carbonization has been used over the years, but then it produces large amounts of carbon char and a large amount of heat is lost during the process. So in our project, we've developed an in-house oven which carbonizes at a faster rate, and the amount of heat lost is lesser than that of the open air carbonization. And then after the carbonized hydroxyapatite is then fused with polylactic acid and then using our 3D engineered printer to print PLA bioscaffold. The bioscaffold derived from this project can be used to treat bone fractures, especially in the elderly population suffering from osteoporosis, which is a defect caused by low bone density.
Is guiding the design, development, and the execution of our solution are fabrication of the oven using mechanical design, heat and mass transfer, which is guided by the law of thermodynamics to determine the heat required to carbonize the bovine, heat generated and the heat lost. Then synthesis of hydroxyapatite using chemical and mechanical method, particularly solution generation method. Then melt mixing of HAP and PLA biocomposite using extrusion techniques of polymer processing. Then 3D printing of HAP PLA biocomposite using digital fabrication technology and computer-aided design, particularly SolidWorks. And lastly, the treatment of the fracture using the scientific knowledge of regenerative medicine and nanotechnology.
The targeted population for this our solution is the elderly population suffering from osteoporosis, a defect linked to low bone density. These bone fractures have been linked to more morbidity and mortality rates in Nigeria and Africa at large. A study predicted the cases of bone fracture will rise to 6.25 million by the year 2050 in the elderly population, which unknowingly going to affect their quality of life and independence.
For the first phase of our project, which is the fabrication of an in-house oven for the carbonization of hydroxyapatite, we were able to produce and test a prototype which yielded high efficiency. While for the production of the HAP-PLA bioscaffold, we are able to form the HAP-PLA biocomposite, but we are yet to produce the filament which we are to use in 3D printing the bioscaffolds. Our future goal is to actualize our solution by continually producing AB-type hydroxyapatite and PLA bioscaffold so as to significantly reduce the population of people predicted to suffer from osteoporosis in the nearest future within Nigeria and Africa at large.